So again, you're here for moving students from the red zone in math with GED testing service, and I'll turn it over to Melissa, who will get us started.
Thank you so much, Lindsay. For those of you who don't know, my name is Mellissa Hultstrand. I'm the Minnesota GED State Relationship Manager. We hope that everyone is well. We are excited to be part of today's conference, and I'm thrilled that my colleague, Debi Faucette, is able to join and lead our math session today. Debi joined GED in 2011, and her move to GED followed an extensive and robust career in adult education and career in technical education at the local, state, and national level, serving as a division director at the Louisiana Department of Education. And as the director of adult ed and GED testing for the Louisiana Community and Technical College system, she was involved in the creation and implementation of the Work Ready U initiative that continues today. Now, as a senior director of GED, she directly serves the needs of partners in California and Arkansas, and she chairs the Professional Development Initiative, which allows her to engage with many states across the GED network of partners. So now, without further ado, here's my colleague, Debi Faucette.
Thank you, Melissa. And I did remember to unmute myself. That's a very lengthy introduction. I want you also to know that Melissa Hultstrand does many, many other things in GED testing service and is fortunate to be the state relationship manager for you all in Minnesota, as we all wear many hats in the testing service. And as you listen to my introduction, all that means is I've been in adult education for over 30 years. I know what that sounds like. I remember when I was a young adult educator and I was with my colleagues and the veterans of adult ed, and I thought, gosh, you know, I can't see myself ever in that job for 30 years. But as many of you will learn, if you're just starting your career in adult ed, it's a passion, you're going to love it, and it's very hard to walk away from it. And I can't ignore the great opportunities I've had to meet people all over the country from through GED testing services. We work primarily, I do, as she said, California and Arkansas, but I get to help with all of the professional development initiatives. So I was really pleased, and thank you, Melissa, and thank you, the Atlas Group and our Minnesota literacy people for allowing me to come in today and doing what I like most, talking with teachers, seeing if we can help you in your day-to-day work, because as you could hear from my intro, I've kind of done everything from starting as an adult ed instructor in a night school to running a local program, then going to the state office and finished out my career there as the state director for adult ed and GED. So it's a lot of fun, and I'm glad to talk to you about math because it's a really exciting time for us because of some work we've been doing with our content area specialists to understand. So as we roll through today, it always takes a little bit for my computer to decide how it wants to address the slides, but now we've got it. So what we're going to talk about today is we are going to discuss some of the challenges that students face in mathematics. What we've learned from our content experts in math and our test assessment and development team, they've looked at the research and we've addressed some gaps that students are having kind of across the board that they have in their knowledge and skills that they're going to need to pass this math test. And so we now have the ability to share that with you and to really hone in on some of the just back to basics. Because when we talk about moving them from the red zone, we're talking about those that score below passing. And I know it's a tremendous frustration because so often they think, oh my goodness, if I'm this far down, I will never pass math. Well, yes, they can. Nobody said you could do it in 3 weeks, but you can strategically go back to the things that sometimes we forget and assume that they should have had anchored in their minds by the age, of the 5th or 6th grade, and it's just not there yet. So we're also going to talk about it. Then we're going to share some of the ideas and resources to support you. Everybody knows this slide. I don't know how often it's been updated, but this is the NRS data. And if you will just allow me this, I am going to take myself off of video because I do find it very distracting to have this talking mouth over on the side of the screen. And now we can focus on what's in front of us here. But you understand the skills that students have and are expected to get in the national reporting system. And very often when they're in the red zone, they are working in that low intermediate basic education level from grades 4 through about 6. So we know we've got to move them along the spectrum. And as you can see in each one of those, the skills that they have to perform become greater, a larger number. Just understanding math operations and the 4 basic skills and the whole numbers is in the low intermediate. Then you're going to make sure, excuse me, that they understand whole numbers and fractions, can work and convert from fractions to decimals and decimals to fractions, and that they can perform. And then at the low adult secondary level, they're looking at the low basic math functions with whole numbers, decimals, and fractions. We're going to keep them moving until we get them where they need to be to pass the GED. And what we know about that, because we are looking at our score indicators, when we talk about the red zone, that means they're not likely to pass. They're in the 100 to the 133 range. That means that less than 50% of the time they can be consistent. If you know these are the ranges from red zone 100 to 133, too close to call 134 to 144, to likely to pass at 145 to 200, we understand where we need to move. The difference in those levels in the range that we look at is based on a student's consistency, their performance. They're typically based on a consistency in demonstrating the skills. And I'm going to show you an example of that. And some of it may be based on the complexity of the materials. We understand that the lower performing student may be more successful with the simpler materials and less successful with things that are more complex. And yes, because we have the 4 performance levels from below passing, passing at the high school equivalency level, the college ready level, and the college ready plus credit level, a person can pass their GED by passing levels 1 and 2. So of course, they may be less successful with the problems that are on the test that are at the higher levels. But what those ranges really mean, as I had said, is if they're not likely to pass, they are very inconsistent. They may see a problem with fractions today on a quiz and pass it. They may see the same kind of skill tomorrow, and they may not be able to pass it just because they kind of know what they're doing, but they can't show you consistently that they can perform the task. In the too close to call range, they're performing about 50 to 70% of the time consistently in that type of skill that they are taking and addressing on the test. And if they're likely to pass, they show consistency in similar skills over 70% of the time. So that may be a better frame for you to understand how we look at the ranges on the GED Ready Score Report. Everybody knows what these are. What are the skills they need to have, and what do they need to do to pass the math score? You and I both know that they need to be able to perform the majority of the skills that are listed on levels 1, which is below passing, and level 2 of the performance level indicators, which is the high school equivalency. They don't have to do everything in both of them, but obviously they have to be able to do a majority of the things in level 1 so that they can move and progress to level 2, the high school equivalency level. So that is where the students need to be to pass the test. We're going to talk about specific item types, but before I did that, a word of advice. We know that we have to help our students think differently about math. They hate it. They go in telling you that's their one hardest subject, but the bottom line is we have to get them over some of the fear of math. And there are ways to make some things in math fun. So we never want to forget about using brain teasers to develop reasoning ability. It's fun. It's a no harm, no foul process. There's usually a little bit of humor involved in it when we're working with this. And if they can find some success in some brain teasers that they never even thought of as a math issue, all of a sudden it opens the door for them to believe that they can take on this math task. And it helps to decrease the math anxiety. And also it focuses on reasoning, because we have to remember, this is not just a computation test. It is called mathematical reasoning for a reason, because this is a test that will ask them to problem solve and use their reasoning skills. Because in the paradigm of developing this test, we had 4 linchpins about what do we want a student to be able to do when they pass their GED. Of course, we want them to have the content knowledge in the 4 areas that kind of represent the major and lasting outcome of a high school education. But they may never see these kind of problems again. They may never see or be asked to solve a question or provide information as they see on this test. But to get to the solutions or the answers on that test, whether it's math, science, social studies, or RLA, they have to use these 4 skills. They have to be able to problem solve. They have to be able to reason. They have to be able, in the writing portion, to understand how to find evidence in the text that they're reading to provide an answer based on the text that they're reading. So there are things that they have to be able to do that's incorporated in math. That's why it's a mathematical reasoning test. And if we remember that, but then we want to make sure we reinforce the basics. And these are a lot of the things that I shared with you that people don't often think they have to go over, because they do believe their students have already picked up these skills somewhere along the way. And we're finding out that they need a little more emphasis on the beginning. We know that in their learning, if you want them to understand, you have to track it from the concrete, where they can see it and touch it and feel it, and they can manipulate and do hands-on and have concrete materials, to actually move around and see how those numbers or counting certain amounts interact with one another. And once they kind of can see it and touch it and feel it, then you can move to looking at a sheet of paper with having students draw and observe diagrams, or watching you move something around on a whiteboard, or moving around on some hands-on materials. But you can go like to the 2-dimensional. You know, you're working in the concrete in 3 dimensions, then you can move to representational in 2 dimensions. And when you have that understanding, where they can sort of see it on a piece of paper and understand how to move it around, that's when you can go to the abstract model, when you can start talking in simply numbers and mathematical symbols. And ladies and gentlemen, sometimes that's a hard thing for us to remember, but I know you all are grounded in this pedagogy, so I have a feeling this is something you already do in your classrooms, and I put this in here just to validate you're doing the right thing. This is where you need to be. But so often when we work in print materials, or even on the digital material, working on the computer, we go straight to the abstract. And that's a very difficult construct if they don't have the background. Those numbers are just a jumble of things moving around on the page. So it's very important to remember how to progress them in their understanding to get them to the abstract, and then you can roll it along. So one of the most important things on this test, and everybody knows this, is the first few items on the test, they don't get to use a calculator. And these are the quantitative items on some of the quantitative items on the test. We're going to talk about why it's so important to focus on this. And if you've looked at your folder, I have included this handout for you in the folder of the calculator prohibited indicators. In other words, there are skills we expect students to have. They're part of our performance level indicators, and they don't get to use a calculator to work a few of these at the very beginning of the test. But you know what? On the rest of the test, these same skills are embedded where they can use the calculator. Just for your information, and some of you probably already know this, the reason they don't use the calculator on these, and yet they will be using these same skills later in the test where they use the calculator, is testing their cognitive ability. Do they have the cognitive ability to understand the reasoning in these particular indicators or in these quantitative computations? That's why it's done without the calculator. If you focus on these indicators and make sure that they are really honed in on that, you're going to help them tremendously as they move to the next part of the test, where so many, everything has more than one process. There's just about no test item that I can think of or that I've heard from the assessment people that is less than a two-step process. So these prohibited indicators are very often an integral part of reasoning through a problem in the latter part of the test. So I know that's a very busy screen, but two things we want to make sure. They need to understand number sense and number order. And we often forget. I mean, you and I have looked at number lines ad nauseum. We know what they mean. We know where the zero is. We know what goes up. We know what goes down. A lot of students don't really know how to use a number line. Don't overlook the importance of the number line. And looking at things in a linear fashion is very, very good for our students because most of them think in a linear fashion. It's great for you to be able to show them comparisons of the size and the amount that a fraction takes up on a number line. Also, another basic thing, make sure they understand what absolute value is. Nothing more than how far a number is from zero, and it doesn't matter whether it's positive or negative. That's what those two upright parallel lines mean. What's the absolute value of a -5? Well, there's no such thing as a positive or a negative and an absolute value, so it's just 5, okay? But make sure they can see that on a number line if you ask what absolute value is. I know these are very simple things, but these are the things that when they're grounded in this stuff, they can move on to the next skills. They do fairly well with equalities. They understand equalities because it's equal, and equal is comfortable. Inequalities are not comfortable. It's just a statement that defines a range of values. And I tried on many of these slides, you will, well, that didn't work out. At the very bottom, I know we say oftentimes, oh, it's on the website. It drives me crazy for somebody to tell me it's on the website because so are 10,000 other pieces of information. So we try to include the URLs if you want to go straight to this page and talk about some of these archived sheets that will help you. Just make sure they understand the difference in the examples that I've given you and how do they express it on the number line. So we're still talking about number lines, but now we're talking about how do you express inequalities on a number line? You know, obviously the The completely circled in dot over the 2 says he runs at least 2 miles every day. So the 2 miles, we know he's going to run that plus more time to the right. If it's less than the -4, on the 28th, Alaska is expected to be greater than -4. Well, we're not going to be at -4, but we're going to be greater than -4. So we would simply circle our starting point because the -4 is not included in the inequality. It's everything beyond or to the right. Okay. And less than 9. That's why the 9 is not circled. And then the T is less than 6. Again, you can see the square down at the bottom and moving it to the left. So inequalities related to the number line, we know they have issues with inequalities. Make sure, and you tell me, I hear all the time from teachers that my students, they don't understand that they can't multiply and divide with decimals. Jiminy crickets, we were doing that in 3rd and 4th and 5th grade. And those of us who wound up as teachers got it. But our students didn't understand the operations on rational numbers. And we have to be creative in how we explain. Many of our students have learning disabilities. I had a daughter who is ADD, and the more processes you gave her, the greater the margin of error was for her. Fortunately, we all know there's more than, as we say down here in Louisiana, which is my home, there's more than one way to skin that cat. Don't you worry, I'd never do that. I have cats in my house, but nonetheless, every problem has more than one way to find a solution, just about. So help them find the way to be able to multiply and divide with decimals, to compute with those fractions and mixed numbers and negative numbers. Make sure they're using the order of operations, and we'll show that in a second. But to most of all, be grounded in number operations and number sense. If there are multiple ways to show how you would multiply or divide with decimals, show them, because there's a chance one of the ways will click for them, even though it may not click for you. And if any of you were with us on our Tuesdays for Teachers last week, we had the math content expert, Michael Bell, and it's spoken as a true mathematician. He said, what attracted him to the beauty of math was that there is more than one way to find an answer in just about everything we do. And that was what he thought the beauty was. There's more than one solution to any problem. Let me take a breath right there. Are there any questions that I should come back and take a look at? And I'll ask that of Mellissa and Lindsay.
I didn't see any questions posted yet, Debbie.
Hey, that's great. That means I'm either rolling too fast or you haven't had time to think of it. So hang with me here. All right, fractions. I've included in a handbook that I have for you this grid sheet so that you can actually print it off and run it out and have students use fraction tiles. It is a linear model. We know our students do better in linear. I bet all of us saw it in pie shape, and you know what? Pie shapes, we just don't have the visual acuity or definition to see the differences in those sizes like we can see in a linear model. So we want to make sure that we are using a linear model. And this kind of gives you an overview of the size and the dimension. And when they look at it, they can work their way down and see how the different sizes in the fraction tile relate to one another. So you want to use those fraction tiles. Well, let's not use the slices of pizza. That's not what we want to do. And you can use it to ask questions, which is more, 3/4 or 4/5, and have them just line it across. It's very important that they could shade this out. So it's a visual prompt. It's back to the basics, but it works. Another way, and I really like this, many of you probably use this, is how to simplify fractions. They don't understand the connections. We memorized our times tables. Some of them still remember them, but there was no connection in their brain. I just rotely knew what 2 times 4, 2 times 5, 2 times 6, 2 times 10, but I never saw the beauty of it in this chart as 1 to 10 down here, 1 to 10 across here. And if you have them put a finger, say on the, let's see what this pops up, you know, across the board. Now I know that 1/2 can be all of these numbers. I could go all the way down, you know, I could look at these numbers. It helps them see a correlation in numbers and how to simplify fractions. This is just a great tool. They can use their left finger up and down, their right finger across, bring them together and get their answer, but they also see how that answer relates to other functions across the line. So we want to try to make sure our students, you know, I can show them 21/28 and I can go all the way back here and realize, well, my goodness, it's related to 3/4. All of these could be reduced down. They begin to see that the numbers actually do relate to one another. So these on the screen are a bunch of different examples that we used, and I'm not going to go through all of them. But the bottom line is, this is a great way to visually help them understand, I learned those times tables, and this is what it really meant, and this is where it came from, and this is how they are all related. I've included this sheet, rules of exponents. They have difficulty with exponents. So this is a kind of a prompt sheet that I used to put in all of my students' notebooks. Let them have it. Let them remember. And I like it because it's not just the rules of exponents, but it also gives you an example. So make sure they understand exponents. They're going to see it on the test. It's going to be there. It's in one of those it could be one of the calculator prohibited items in the top part, but I just think it's critically important that they do understand exponents and how they work. And just like we did the fraction tile chart, we have to make sure that they understand squares and square roots. We would want our students to understand the square roots up to about 140, up to 12 times 12. And so that's what we've included here. Again, there's a connection as we go down, as we can go, there it is. As we move down, take a look. They can square this and look at the symmetry of how this works across here. Sometimes just seeing that is a comfort to people who have a different kind of visualization of things. So I would tear this sheet out of your workbook that's in there, and I would put this in their folder. Just take a look at it. Instead of worrying about multiplying it, understand that there are relationships here. Also, in those calculated prohibited items, you may have something about percents, ratios, and proportions. These are still areas where students are very inconsistent. And so much of that has to do with, we may teach them a trick, draw that circle, put a line in the middle, and put the different types of formulas in the quadrants. But they just learned the trick and they know how to plug the information in, but they don't understand why it works. So be certain that they understand percent is out of 100. That ratio, they're related, but they have different ways of being expressed. A ratio describes the part-to-part relationship, and proportion describes the part to the whole relationship. That's it. That's what we want people to understand. And this is something that really does well for looking with your, using your manipulatives. Whoops, sorry about that. Because if you put 100 things in there and you had them colored out, all of a sudden I've talked about the ratio the percent, and the proportion. Okay, so percent, let's see, I'm having trouble moving this thing out of the way. Okay, but at any rate, you understand how to use a very visual tool to talk about ratio, proportion, and percent. Okay. Ratio and proportion also use those graphic organizers. But the problem here is make sure that when you use the graphic organizer, that they actually understand why it works. Because sometimes just memorizing that picture of where I put things in for a ratio problem won't help, because we understand that if they don't understand the why, they can't go back and perhaps manipulate that formula. If I don't ask you for the ratio value, but I give you the ratio value and the base, can you tell me what it compares to? That's what we really see. And most of all, don't forget probability. And this is just a basic thing on probability. Basically, it's the number of favorable outcomes. It's sort of like a fraction. To find basic probability with all the outcomes, we'd use a fraction. The favorable outcomes over the total number of possible outcomes. And here's an easy one to look at. If I have 10 marbles and 4 are red and 6 are blue, what's the chance I'm going to draw a red marble? Well, 4 out of 10, because that's how many marbles I have. You know, red marbles I have in the mix. Again, very visual, very kinetic. They also still have some real misconceptions about the order of operations. And I think we were all raised understanding PEMDAS, but we found some of you may use a more current, another way to talk about groupings, and then you work on exponents, then you multiply and divide, and the only rule is you go from left to right, and then you do the subtraction or the addition, again from left to right. And you will have these misconceptions. You know, the first one talks about how all multiplication should be done before division. Well, no. You do the multiplication and division, but you do it from left to right. And so you can see what they did on the incorrect version here, but the correct version. And the same thing here, all addition comes before subtraction. No, you just simply do the subtraction and addition after you've done the groupings, the exponents, the multiplication and division, and then you go left to right for subtraction and addition. So those are some of the basics. And according to our math expert, our students are still having trouble with some of those very basic concepts. And what he expressed to us in our Tuesdays for Teachers was that has to be solid, because those are some of the processes they will use in the remainder of the reasoning and mathematics test. It's not the only process, but it is one of the processes that may be used. But let's talk about the reading and reasoning in mathematics, because we talk about how important reading is across all the content areas. But if we really want to analyze those math challenges, we know that it requires the application and development of quantitative and algebraic reasoning skills. Well, we've been talking about quantitative, basically talking about quantitative reasoning skills. And when you're doing that, we've already said you want to get past the application of formulas, just memorizing it, but understanding the why and the how. And all of you already know to use real world examples. In strong critical reading and thinking of any of the math problems, the question is, what are they asking me to do? What heuristics can I use? And I always give credit to Susan Pittman for making me look up heuristics. Basically, that's what's your problem solving method? A heuristic sounds hooty tooty, but basically, what problem solving method can I use? And when I'm done and I try to work the problem using that method, is the answer reasonable? Does it make sense? So those are the analyses of our math challenges. This screen we have used many times, and we use it in just about, well, we use it primarily in math and in the RLA, because whether you're doing an extended response or whether you're reading a math word problem or really any of your math problems, but primarily the word problems, you need 3 reads. A little different purpose in the RLA, but in math, you're going to read it for understanding. Just read the thing all the way through to the end, please. Because if you start trying to solve it as you're working your way down, chances are that's not going to be your best process. Read it to understand what they're asking you to do and what information they are giving you. On the second read, that's when you go back and go, okay, now I know what they're asking me to do. What problem-solving process am I going to use? All right. And we're going to decide on a process. And then in the third read, we're going to solve it and we're going to see if it makes sense. And you will see we give credit to the authors of this particular thing, but we have found it very practical to use the 3-read process. Most of all, you tell them on that first read, don't stop until you get to the end. No matter how much you think you need to make a note, get to the end, figure it all out, then come back and identify, okay, now I know what they want me to do. How do I solve it? These are all the kind of questions that you'd want in the first read. You know, note your reactions. Are there vocabulary words you don't know? What's the real world context of the problem? Did they give you even a picture that can help you visualize it? And most important, what are they asking me to do? In that second read, it's, okay, what's relevant in this problem? And that's a hard thing for us to get our students to understand. I know in the RLA, when we'd ask them to say, just underline the relevant information or highlight the relevant, I'd get back a sheet that was totally highlighted. So this is a skill in itself. Figure out what information are they giving you that's useful, and did they give you anything in there that's not something that needs to be considered to solve the problem? Which of these problem-solving things am I going to use? Which is best suited for the problem? How am I going to represent this in mathematics symbolic language? And what details in math will I select as reasons? These are all the things you think about when you figure out, how am I going to go about solving this problem? On the second read, you are going to identify, these are 10 problem-solving processes. You've seen them before, and I want to tell you that in the workbook, I gave you each of these 10 heuristics, and you have one example of a problem using that method to solve it. And so we're not going to spend a lot of time here. But the other thing that's important here is any one of us can probably pick out 3 or 4 of these problem-solving math things that we have in our back pocket. And depending on what the question or the problem is to solve, we'll figure out which one of our problem-solving processes we want to use to address it. Our students don't really have these problem-solving processes. They may be like me. If it's the right kind of problem, I'll guess and check. You know, okay, I think it's this. Let me work the problem this way and see if it makes sense. Or if they give me an answer, I love to work backwards. You tell me what the answer is and I can tell you how you got there. All right. But not every problem can be addressed in that way. But you're going to have to help them understand problem-solving processes and help them build their repertoire, especially in math. And this is an example of one of the 10. I like this one. I like to draw this. I mean, if you think I can read this and mentally make that picture in my head, I cannot. But it's a stock car race. The first 5 finishers in some order were a Ford, a Pontiac, a Chevrolet, a Buick, and a Dodge. And then based on these bullets under here, I'm going to draw a diagram that will help me figure out what order they came in. So this is an example of drawing a diagram. Again, it blurs my mind to try to read it and process a visual picture of here's the Ford, here's the Pontiac, here's the Dodge, here's the Chevrolet. I can't work like that, okay? But this is something that you can have your students do. Just draw those lines right in there. And the order is, now, like I said, in the workbook, you're going to have an example for each one of those 10 things. So I'd urge you to take a look at it. And the third read, well, we've already talked about this. I understand it. How can I use my math skills? Am I answering the right question? And did the answer seem to make sense? That's pretty self-explanatory. The next thing that we have to remember is if we're going to help our students, we also have to help them build their vocabulary. And in building their vocabulary, everybody's seen this group of tiered vocabulary. Where we want to work is in tier 2, which are the utility academic words that you can find across content areas, and in tier 3. I added this into your workbook. Make sure your students know these words because they're going to encounter them somewhere in math. You and I look at this and go, seriously, we have to define these? And seriously, yes, you do. They will know some of these tier 2 vocabulary words. They may not know all of them, but they're all important to being able to solve the math problems. Tier 3 math vocabulary words. Here are some words. And again, the website for this is down below, but just look at these different words. And even like dependent variable, you're going to see that in science. You're going to see a lot of these words between math and science. So help them with their math vocabulary. Do not neglect their math vocabulary. Next thing we know, lots of problems in geometry and geometric reasoning. Well, here we go into these different parallels. And I took this straight from our Tuesdays for Teachers sessions. Here's a skill that they have difficulty with. And we want to look at different ways to teach them to kind of get that light bulb to go off. They are going to have to understand what shapes are. They're going to be asked to deal with prisms and pyramids and cones and cylinders and spheres and composite figures. These are all very important. And you can see above the quantitative reasoning skill indicator number 5. They're going to have to calculate surface area, volume, and determine dimensions. The biggest thing we see that they're having trouble with is identifying shapes and understanding how to manipulate the formulas. Because if you remember, the formulas for surface area and volume of all figures assessed are provided on the GED form. I would hesitate to say that perhaps we need to go back and make sure they're familiar with those formula sheets that can be downloaded off of the website and put right in front of them. So it's a refresher. How do you use the formula sheet? When I'm looking at the problem, how do I look over here and determine what I use next? How do we build their geometric reasoning? What we know is that they do not visualize, they don't have the vocabulary. Again, the manipulatives come in so handy. These are just implications for instruction, things you probably are already doing in your classroom. Make sure that we have activities that help them sort shapes and identify and describe the shapes. You and I, for example, would look at that diamond. Chances are they'll say, that's a diamond. They would never think to say it's a square, it's a parallelogram. It's all these different, they need to increase their ability to describe the properties of the different shapes. They need to build and draw them. They need to put them together and take them apart to see what's equal and not equal. We want to make sure, and just like I said, see the shapes in different orientations, like the diamond versus the box, and make sure they see different sizes of each shape. So it's visualization. If they can't visualize it, we're not going to be able to move them along to the analysis phase. Make them use words to identify the properties of shape and to use an appropriate vocabulary. Most of them cannot explain the relationship between shape and properties. In other words, they're going to know it's got 4 sides, but they may not be able to tell you why the second shape is not a rectangle. If they don't know the properties of a rectangle, they're just going to know they're different. We know they're 4 sides, but what makes it different? So talking about shapes, every property you can use to address a shape is very important. So again, we said work with manipulatives, define properties, and look for patterns, and talk about what happens in a shape if you change a property. We talk about what defines shape. We use activities that emphasize classes of shapes and their properties, and classify shapes based on their lists of properties. So if we've covered the basics in number sense and number order. We've talked about geometric reasoning. We've talked about quantitative reasoning, geometric reasoning. Let's get to algebraic reasoning. What is it about algebra? Well, people looked at the 2014 test and said, oh, you've got algebra on here. Ladies and gentlemen, we've had algebra on the test since I was looking at a test in 1988 version, you know? So, but the difference is the amount of algebra that's on this test. So it can't be hidden. But we also know they have a much smaller skill repertoire, because we've already talked about they don't have the ability to work with, they can work with equalities, but not inequalities. And they're very weak in graphing and charting and the graphing skills. They are less able to put real world situations or to interpret real world skills mathematically in algebraic language. And they're far less consistent in their performance. They're going to hit or miss more there. Because remember, arithmetic is very different from algebra for the reasons stated there. In arithmetic, you're doing something to numbers to get an answer. But in algebra, you're exploring the relationships between numbers. You're just looking at the relationships. Very basic, simple things. Our minds switch gears back and forth between arithmetic notation and algebraic notation. We don't even think about it. But in a student's world who's not spent a lot of time in algebra, take a look at the difference and make sure they understand what that sign means in arithmetic and what that sign means in algebra. Little bit of a difference there. Okay, but symbolic notation is very important for them to understand and be able to cross that language from arithmetic to algebra. There are 5 basics of number knowledge that are essential for algebra learning. Understanding equality, recognizing the operation that's being requested, being able to use a wide range of numbers, understanding important properties of numbers. That goes back to, you know, the absolute values, the positives, the negatives, and they need to be able to describe patterns and functions. So those are some essentials. And in order to do some of that, here's another sheet that's in your workbook. I would urge you to put this in a notebook because it's a math translation line. We don't often think about going from arithmetic or arithmetic notation to written language, or from written language to math, you know, symbols and things. But I love this translation guide because it has the English definition. Then it has, okay, what that would look like in a math notation. And then it gives you an example in written form, and it translates it into the math form. These are very helpful to students to kind of be able to piece together and make some sense out of moving from English to mathematical notation and math notation to English. Here's a great one. I love this one. And believe me, I got it wrong as I read it quickly. But if it says Jennifer has 10 fewer DVDs than Brad, if you just started translating across, you might say, and we give you the common answer, Jennifer has 10 fewer. Oh, fewer means minus. So I'm going to put a minus 10, and that would be equal to Brad's. All right. But if you insert the words and see the difference in the equation, Jennifer has. Okay. So this is what she is, what she has. What she has equals Brad's minus 10. And so Jennifer would have Brad's number minus 10. Do you see the difference in translating? So make sure they understand how to translate. And to do all of these things, you would go to our educator and administrator website at GED.com. Right there, click on that, and you will find all sorts of resources. I included these resources in the guide. You can go and find the computer tutorial, the calculator tutorial. I think it is negligent of any of us in the classroom if we do not make students go through the computer tutorial to help them have a comfort with accessing the test. And more importantly, the calculator tutorial, have them understand and work with the calculator reference sheet, with the formula sheet. You have the free math study guides that are under free classroom materials on the website, and the calculator prohibited indicators. These are fabulous resources that can go in their notebook that you can use to store and show things. Wow, I did that again. Oh, instructional resources. I included these in the web. I will be posting, I've shared the PowerPoint, and in the end of the PowerPoint, I posted a sheet on each of these so that you could find the URL. But I'm sorry, let me go back to this. Every one of these listed here, the 5 listed, when you open up the PowerPoint, you will see a picture, a screenshot of what is included in that, in each of those literacy resources, and the link to open up and explore for yourself. We really love the GED Math Crash Course. That's created by one of your colleagues, an adult ed teacher out in Arizona, Kate Redmond. And we go to it a lot. We like Math is Fun because the multiple languages that you can put things into from there, and just so many other things that are right about it. And most of all, let's just remember and help our students remember, we all have this version of what we think success is. And actually what success really looks like is a very messy back and forth pattern. And our students need to know that we expect it. We're blessed if they are that straight line that goes straight up, but we and they should be prepared that many of the challenges we face, success looks a little bit squirrely and we kind of wind around and we come back. But you know what? Eventually we pull through it. At this point, I'd like to ask if there are any questions or anything we need to repeat or to share. And while you're answering questions, I want to make sure that you know that you can communicate with us. I would think your first point of contact would be Mellissa Hultstrand. She is your person in Minnesota. I tell my people in California and Arkansas that I'm your person. We have lots of people and human resources to help you with issues, both on the GED testing service side and operations and so many other areas, and with our Pearson VUE partners. If you feel like somewhere along the line, we have not responded in a way that is appropriate or timely, that's what I'm the person for California and Arkansas for. And I believe Mellissa will say the same thing. let us know. We will help you navigate. Nobody should be frustrated. And if you can't remember our names and our emails, look up there where it says communicate with GED testing service. If you send an email to help@ged.com, that is viewed daily. And if it shows up with a Minnesota moniker, chances are it's going to go to Mellissa anyway, if it's something that the help desk cannot answer, if it's not a real general question. So with that said, may I ask of you, Mellissa and Lindsay, any comments or things that I need to be aware of?
Yes. So Debbie, Abby asked a question in the chat. I'm not sure if you're able to pull it up.
Yeah,
I think
I can't. I've got it on screenshot, so I can't see it. So could you read it?
I'll read it for you.
Okay.
So it says, question about the need to teach the names of geometric shapes.
Okay.
Are you saying there are test questions where as part of the question, if a student didn't know the name of a diamond by another name, they would not do well on the question?
No, well, number one, I'm not allowed to see the actual test questions, but I don't think it is that specific. It is simply that when they are looking at the shapes. No, I don't think they're tested on how many names can they name a shape. But I think in a test question, if you're looking at it visually, you may be able to know that that square is like a diamond, or, because it may be germane to how you're looking at that particular item. But I don't think it's going to be that sort of thing. Okay.
Right. And then Abby specifies, would there be questions that name the shape but don't show it in a picture where orientation or whatever else is preventing students from recognizing a diamond as a square would mean that they can't reason about the problem? Could you give an example of such a question?
What I understand and what I heard Michael say in our Tuesdays for Teachers session, that was, you're asking if something's missing there, that it might cause them to make a mistake. And he explicitly said the information that is needed is provided. So that comment makes me think that would not be the issue that you mentioned. Okay.
Right. And I don't see any other questions right now.
Well, I'm going to give you all the same answer I give to everybody, because I do see we're short. We're going to finish on time, so that's always a good thing. But is there anything else in the realm of GED? I never want anybody to walk into a session and say, well, that was pretty good information, but what I really wanted to know about GED or Pearson VUE was ta-da. So if you have any ta-da questions that have nothing to do with math, it's your golden opportunity, because you've got your state relationship manager here and me. And between the two of us, we probably have some stuff we can share with you if you have a curiosity. You may be more curious about lunch at this point, aren't you? Well, if we have no other questions, again, I'm going to let Mellissa, and if Lindsay has anything to close out with, but I want to say I love coming to this conference with you guys. You have a wonderful team working with you, and I count Mellissa as a treasure we have at the testing service. So I think you've got just the best of the best, and I'm happy to share time with you. You can always email either of us. And so, Mellissa.
Thank you, Debbie. Thank you for your kind words. Thank you for running this session today. I so appreciate it. And Lindsay, thanks for your help, and Susan being there in the background to make sure all goes smoothly. Like Debbie said, if you have any questions, please do not hesitate to reach out. I'd be more than happy to answer your questions, get the information that you're looking for. Have a great Friday and enjoy the weekend.
Lindsay, anything else?